Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the perimeter of the Pentagon? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. This is Pentagon ABC segment DE. Its perimeter is the sum of the 5 edges, segment AB, segment BC, segment CD, segment DE, and segment EA, walked once around the boundary. We need to pin down every side and add them. 4 edges carry labels. Segment EA is 3, segment BC is 5, segment CD is 7, and the long base segment AB is 9√3. Only the slanted edge segment DE is unmarked, so it is the one quantity we must recover before we can add. At corner A, the edge segment EA stands square to the base segment AB, and at corner B, the edge segment BC also stands square to segment AB. So the Pentagon has right angles at A and at B, giving 2 clean horizontal walls to lean on. Because both segment EA and segment BC are perpendicular to the same base segment AB, they must be parallel to each other. That gives 2 horizontal walls, and the vertical gap between them will matter in a moment. The vertical distance between the 2 horizontal walls is exactly the base length segment AB, 9√3, because segment AB runs straight from one wall foot to the other. Hold on to that gap. The perimeter is segment AB plus segment BC plus segment CD plus segment DE plus segment EA. 4 of these are already in hand, so the whole problem collapses to finding the single missing edge segment DE, the roof line running out to the peak D. Here is the plan. If we know how far the peak D lies to the right of the base, we can split the roof into 2 right triangles and trig out segment DE. So our first target is that distance out to D. Through the peak D, draw a vertical line parallel to the base. Extend the top wall out to the right to meet it at a new point F, and the bottom wall out to the right to meet it at a new point G. This slices the roof into 2 right triangles we can handle. The quadrilateral ABGF has 4 right angles, so it is a rectangle, and opposite sides of a rectangle are equal. Therefore, segment FG equals segment AB, 9√3. The full span along the right side is 9√3. Where the vertical line meets each horizontal wall, it forms a right angle, so the corner at F and the corner at G are both 90 degrees. Each of the 2 roof pieces is now a right triangle. Take the right triangle DCG first. Its right angle is at G, and its hypotenuse is the known edge segment CD of length 7. We need one angle to unlock the legs. The interior angle at C is 120 degrees. Since segment CG is the straight continuation opposite segment CB, angle DCG is its supplement, 60 degrees. Aha! The 120-degree interior angle leaves a 60-degree roof angle, so the lower roof piece is a 30-60-90 triangle. The upper piece will inherit the same pitch. The horizontal leg segment CG is adjacent to the 60-degree angle, so it is 1/2 of hypotenuse segment CD. Half of 7 is 3.5. The vertical leg segment DG is opposite the 60-degree angle, so it is √3/2 of the hypotenuse. That makes segment DG equal to 3.5√3, a value we will reuse in the closure check. As a sanity check, 3.5 squared is 12.25, and 3.5√3 squared is 36.75. They add to 49, which is 7 squared, so the legs match segment CD of 7. Now, stack the distances. Point C stands 5 to the right of the base, and D lies a further 3.5 to the right of C through the leg segment CG. So the peak D is 8.5 to the right of the baseline AB. Turn to the top roof piece, triangle DEF, with its right angle at F. Its hypotenuse is the edge segment DE we are hunting, so if we can pin one leg, we can solve it. The horizontal leg segment EF is the gap between D at 8.5 and E at 3. 8.5 minus 3 is 5.5, so segment EF is 5.5. At E, the given interior angle is 120 degrees. Since segment EF continues opposite segment EA, angle DEF is 60 degrees. So this is the same 30-60-90 shape. The horizontal leg segment EF is adjacent to 60 degrees, so it is 1/2 of hypotenuse segment DE. Since segment EF is 5.5, segment DE is 11. The vertical leg segment DF is √3/2 of segment DE, which is 5.5 √3. We keep this to confirm the whole roof fits the span exactly. Aha! This closure is more than a check. It solves segment DE in one line. The 60-degree projections of segment CD and segment DE fill segment AB, so 9 √3 equals 7 plus segment DE times √3 over 2. Therefore, segment DE equals 11. Now every edge is known. Segment AB is 9 √3, segment BC is 5, segment CD is 7, segment DE is 11, and segment EA is 3. 4 whole numbers and 1 √3 term. Add the 4 whole number sides. 5 plus 7 is 12, plus 11 is 23, plus 3 is 26. The rational part of the perimeter is 26. The base segment, AB, contributes 9 √3, which stays separate because it is irrational and cannot merge with the whole numbers. So the perimeter is 26 plus 9 √3. Numerically, 9 √3 is about 15.59. Added to 26, the perimeter is roughly 41.59 units, a sensible size for the drawn Pentagon. So the answer is 26 plus 9 square root of 3. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.